right, people. So we should have last night's homework, 2.1.2. If you need to update your plan book, we did push 212 to last night's homework. It was Tuesday's homework, but we extended it into last night. Put your eyes on the board so I know you're actually listening to me. I changed my mind. We're collecting homework on Friday. So, if you have questions on 212, it would be a great idea to ask them right now to help you get them done. Because our mini mastery tomorrow is also going to be on the section 2.1, which notice we're moving on. We're moving into a different section today where it's all about like adding and subtracting integers, which is whole numbers. No decimals, no fractions, which a lot of you, that might be like a sigh of relief. Like, oh, we get to walk away from those partial numbers for a little bit. So, because we're switching gears, we should probably take a mini mastery and check, did some of that information stick? So, as a note on fractions that you could put in your notes if you want, or you don't have to, I have it up on the dry erase board, and we'll probably leave it there. Reminder, the numerator, because this vocab some of us were iffy on. Cough, cough, hint, hint. This is going to be on your quiz. The numerator is the top number. It is how many pieces we're talking about, like how many pieces of pizza I ate last night. I'm not joking. I ate pizza. I ate 3 of them. 8 is the denominator. It's how many it takes to make a whole. The pizza was cut into 8 slices. And then the Terminator was Arnold's best movie. It's not funny because you guys don't know what I'm talking about, but it's funny to me, so that's what matters. Yes, the Terminator movie, where, yes, he comes back to, like, save humanity from, like, robots or something. I forget. Alright, so I gotta get back papers, but we should check homework first. So if you don't have homework out yet, get it out, please. 426. We were trying to determine, are they going to repeat or are they going to terminate? So when we try to turn A into a denominator of 100, it turns my numerator into like 13.3 repeating. I don't know if you can see the repeating bar there, but it's 13.3 repeating. So that's bad, right? When there's a repeating decimal in my fraction, that's bad. It told me we're going to be repeating. You do not need to write down the terminator, by the way. The thing on the dry erase board, that's just a joke. But terminating, remember this means terminating, it stops. So the Terminator, actually, he had the name the Terminator because he ends people or ends things. But so this terminates because I can make it into 5500ths. This does not repeat. It's good. We like it. I was helping people in extensions, and I left this for them to finish. The multiplication here is times 25, I think. Did anyone do it? Here's a reminder, guys. If you forget how to do this, eyes on the board, please. I'm trying to turn 40 into 1,000. If I don't know how to do that multiplication, divide backwards, and it tells me what to multiply by. So now I know that that is times 25. I do the same on top. Anyone have that for me? Yeah! So this becomes 0.425 or 425 thousandths. It is also terminating. If we try to do the same thing with 1/12, can 12 turn into 100? Ooh. That answer is a repeating decimal. Even if I try to turn 12 into 1,000, it's a repeating answer. So guys, since this number that I would need to multiply by is repeating, this is going to be a repeating decimal. There's no nice way for 12 to turn into 100. It's a repeating number. Questions on that? Yeah, so that's why I went on up to 1,000. Because remember, we either want the bottom to be like 10, 100, 1,000, 10,000. So we can keep getting bigger. if we get a decimal here. But 17 times 2.5, it's not repeating, right? So we know it'll terminate. This may not be exactly what we want yet, but it's not repeating, right? So that's what we're looking for, is it repeating? So if we don't know how to multiply forwards, divide backwards. For 27, because I didn't do all of that yet yesterday because I did other problems for people when they came to extensions. So the missing piece for A was the verbal, the like written out words 5/8. And because B was actually improper, it's 3.3. Guys, you should be looking at your paper, right? It's 3.3. This is actually 3 3/10. So when we go to write out the fraction form or mixed number form, it would be either 3 3/10 or 33/10. For the 28 for our spinner, probability of a heart, star. First one was a star. There are 3 stars on the spinner. And then guys, we can use our calculator. So if we do 3 divided by 8, sorry, I could zoom in on this a little bit more. I don't know if you guys are able to see it real well. 3 divided by 8 gives us 0.375 or 37.5% because we multiply it by 100 to get to percent. If we look at the probability of not getting a diamond, you either could have counted up, there are 7 slices, not diamonds, or you could have done the subtraction. You didn't have to do the subtraction. C, a flower. There are 2 flowers on the spinner. So 2 out of 8 actually reduces down to 1/4. Guys, this is a fraction you should probably memorize. That 1/4, 1/4, a quarter is 0.25, right? It's 25 cents. So a quarter is 0.25 or 25%. And then D was probably the hardest one. So I'm going to show you my paper for D. It said, what's the chance of getting a heart if we spin 100 times? Well, guys, remember, that's the denominator, right? The amount of times we do something is the denominator. So you want to take your probability of hearts being 2/8 and turn it into 100 on the denominator. Well, first I see, 2/8 can actually become 1/4, which that fraction is easier to work with. We get 25 over 100, so our prediction is 25. Questions on the front? Guys, at this point, I'm spending so much time going over homework at the beginning of class, like we should all have homeworks done. The back, when we scale axes. If you had trouble on this, the first thing you need to write down is this. To scale our axes, it's the distance divided by the gaps or jumps or whatever you want. Excuse me. Swallowing down the wrong tube. So, our first one here, see if I can get it in some light. Between 32 and 64, how far is that? It's 32. The distance to get up to the next number that we know is 32. How many jumps were there? There were 4 jumps. So if I zoom down in on this, it came out to be 8 when I did the division. So 32 goes to 40, then to 48, then to 56. Then we hit 64 like we want. Then we get to 72, 80, 88. You wouldn't have to fill in the entire thing as long as I can see that you got the gaps right. Sweet. Sweet. B, I'm going to leave to be done on your own because B is probably one of the easier ones here. If you need help, come see me. In C, X and Y are not the same. And they don't have to be. So I had some kids come at extensions and they say, wait a minute. Don't X and Y have to have the same scale? They do not. So with X, our X-axis here, we do 12 divided by 4 and get that each of those is 3. Whereas for the y-axis, we do 10 divided by 5 and get that each of them is 2. Questions? 23, I'm going to leave to be done, 30, I'm going to leave to be done on your own, but if you want help, come get help. What we really want to do is compare fractions here. How do we compare fractions? What do we do first? Yeah, I mean, 100% would work, but we want common, sorry, that's an M. I know it's not, but we're going to make it one. Common denominators. I can't talk and write. I don't know, maybe. And guys, this is not part of your homework. This was just me trying to fit everything on one page. This is like a cheat sheet in a way. This is notes. So if you are trying to convert decimal to percent or anything, guys, literally, I put this here so you have a nice reference. So I will give it back to you on Monday after I grade over the weekend. Look at this. Percent to decimal, percent to fraction, fraction to decimal, decimal to fraction, fraction to percent, decimal to percent, everything, guys. Even repeating decimal to fraction, what we just did yesterday. Look at that. This is like a gold mine right here. Anything you need to remember. Now, if you can't read this here, right here, page 81 of your book. If you can't read it because it's a tad bit blurry on your paper, page 81 of your book. All right, moving on, but keep this out because 31, our lesson problem, is right here. So keep this out. Cool? Cool. All right, anyone want to read? Let's go Farah, and then we'll probably hop around. So Farah, read our first paragraph here.
Units of length can be placed one after another, and a line defines a measure of an object's length. Today we will look at how to compose, put together different lengths, gray and neutral lengths.
All right, now don't get too excited, but I am a tightrope walker. Not quite, maybe. Anyone know what a slack line is?
Yeah.
So now I gotta see if I can get permission, but I'm wondering if I might be able to bring my slack line into school and let you guys try it. Because when we talk about like Cecil, our tightrope walker, ads, always ads. So if you do not know what a tightrope is, because circuses are kind of a thing of the past. Well, okay, I've never been to one, so for what it's worth. Slacklining is now what people would probably more potentially know about. It's like one of those, like, really dangerous sports. So, you can't go left or right. You can only go forwards or backwards or down, I guess. You don't want to go down, so that's why he's got a harness on. So, when we talk about this in class, we are going to reference our friend Cecil. So, Cecil is an acrobat in the local circus. His job is to move across the tightrope from A to B while blindfolded. He can only move using distances you tell him to move in your instructions. How stressful. He's just standing there waiting for you to tell him what to do. He needs to reach the end of the tightrope, so point B. So, he's always starting at A. Right, he's always starting at A, and he's always ending at B. Now, the thing is, he doesn't have to move the same direction the whole time, because that would be sort of boring. Right, so if you've ever been to a circus, the tightrope walker probably didn't go like, up, I'm done. They probably did something cool, like forwards and backwards and turn around and move around. Like, something entertaining. So that's what Cecil does. Yeah, they probably juggle things on fire at the same time. So, if we want, we can go, there's a little digital thing if you really want to pull up your computer and work it. But here's our task. And we'll do one together. If we have been given the distance of the tightrope, and we are allowed to go forwards or backwards. No, wait, backwards. How do we represent, like, the opposite direction mathematically? Okay, subtraction, or, nah, division splits things up, right? So not division. What's another way we talk about subtraction, but we don't use that word? Negative, right? Or we could even just say opposite, right? Like the opposite of 3. But so here's our first test. Our tightrope is 24 feet long. 24 feet. This is on your paper. This is literally like it's A on your paper. It is on your hand. Yeah, it's I literally said don't put this away. The first problem's on this paper. This is why I try to tell you guys. You can. Now, you guys might want some graph paper if you're going to get really creative with this, because you're going to run out of space pretty quickly. So like I said, every day we should have graph paper out. We can only move in lengths of 2, 4, 8, or 10. So if I'm going to be extremely boring, although a jump of 10 feet is pretty intense, I could jump 10 feet, jump 10 feet, and then jump 4 feet. That my drawing does not do a very good job of showing 10, 10, and 4. Does that get me to 24? Yeah, but that's really boring. So I got 2, 4, 8, and 10. So what if I went 8 forwards, and then 4 backwards? And then another 8 forwards, and 4 backwards. Ooh, I just extended that way too far. And another 8 forwards. And another 4 backwards. This is what some of you guys do with your assignments. You like get some done and then you don't do some, and they get in math and then you get some done and then you don't do that. I could do that, right? And eventually probably get there. I think I could. So here's your task. I want you, for each tightrope span, using both forwards and backwards movements, get Cecil to the end. So, like, do A, talk about it with your partners, and then move on to B, right? We're not in a race. If this lesson goes into tomorrow, that's fine. All I care is that we got done with the 2-1 stuff this week, which we did, so it could work. All right, talk with each other. I'm going to flip my timer and try to be quiet, because I got to pass out papers. Hold on. My hand was up first. For the 20. That's the 17. You can only use 2, 3, and 10. Thank you for asking. Yo, I didn't clarify this quite well enough. When you move on to B and you move on to the 17-foot tightrope, your just even numbers would not work there. Your new lengths for B are over here. So then when you move on to C, the new lengths for C are right here. Okay, so they don't all use the same movements. This is also why I said you might want to use some graph paper. If you write really small, you might be fine. I never finished it, so that's for you guys to get creative. If you want to do it, all I was doing was 8 forwards and 4 backwards, and 8 forwards and 4 backwards, and 8 forwards and 4 backwards. And I think I could get to the end. Because every time I go 8 forwards and 4 backwards, how far did I actually go? 4, right? Because I positive 8, negative 4. So I think I could go 4, 4, 4, and get to 24. Right? So we could do that, but you guys could get more creative and more fun. Yep. No, it doesn't matter. You can use them as many times as you want. You can use the lengths as many. Sorry, I kind of jokingly but kind of seriously say I'm only a so-so teacher. You can use these numbers as many times as you want. Sorry, my directions were not super clear. It's not that you can only use 2, 3, and 10, because that would only get us to 15, right? So, like, we got to use these numbers more than once. So up here, I know we potentially could just use every number once. I think that's what we figured out right there, is if we do 2 plus 4 plus 8 plus 10, it actually gets us to 24. So Cecil could, actually I'm probably going to have you guys move on to B after this, because I think Farah's group figured out, if we do 2 plus 4, sorry, these are all positive actually, I know I'm writing in red, that's 24. So then they asked, are we only allowed to use these lengths once? Nah, you can use them as many times as you want, forwards or backwards. So get creative. I want to see what you guys can think up. So move on to B. Might as well move on to B. Odd numbers are more fun. You could go past point B as long as you come back to it. Does that make sense? There's a platform, right? Because point B is where he has to take his bow, right? You gotta bow at the end. Drive what? Thank you. Do you want to drive race board? You can grab any of those if you want. Those are dry race markers. So you do whatever you want to do. It's your mind. Sure. See me real quick just so I can make sure you understand something. As many as you want. As many as you want. So you have those numbers to work from, like 2, 3, and 10. Well, I could go 10 plus 10. Then I'm past my target. So then I have to go backwards, right? Nah, you shouldn't need to. Yeah, gravity. I walk away and I realize I have 8 pounds. I'm also using this so I can walk around and look at people. That means another check. If you haven't done C, move on to C. If you haven't done C, move on and try it. All right. So I'm not going to draw the picture because it would probably, I'm definitely going to take up too much space if I do. But, Jesus is still gone. We just spoke this morning. Kylie, do you want to give me some directions for how to get to an endpoint of 17 using 2, 3, and 10? All right, so we go 10. And then we go another 3. So guys, notice I already wrote my plus sign. Since I already wrote my plus sign, how do I go back to? Negative. So and you don't have to do this, but I am a really big fan of saying and. So mathematically, and means plus. I don't say takeaway in real life. Like, I never say takeaway. It sounds kind of weird. I say and a -2 or and a loss of 2. Like, if you watch football, they don't say, and the defense did a takeaway of 3 yards. They said they lost 3 yards, right? Takeaway doesn't really get used out in the world. So, I agree. 2 backwards, right? I love backwards because this absolutely means 2 backwards. And then what?
+6.
And then, ooh, so we can't use 6, but I can do +3 +3. Yeah, you're fine. So, this is 13, then -2 is 11, +3 is 14, +3 more is 17, and this absolutely works.
We did it a different way.
Ooh, a different way. This is why I have cards. Deekshita, you got a different way?
Yes.
Go ahead.
So first, go front, +2 to 10.
All right, hold on. I gotta have lots of options here. All right, so +10,
Then -3.
and then -3. I'm gonna end up with ink on me. Definitely.
Then +10.
And then +10. Well, that was pretty simple. So wait, what's 10 plus 10? 20 minus 3?
13.
17. Nice. Let's go one more for B. Eli, you got another one? Whoa, whoa, let the man work. Hey, John, are you Eli? B.
Oh, okay.
Oh, so you were trying to help him. I thought you were trying to trump over what he was saying, which we've been having issues with some kids doing that.
+10,
Okay.
+3,
+10, +3,
-3,
-3. Ooh, doing a little dance now.
+3,
So I need a plus there. +3,
+2,
+2,
and then another +2.
and another +2. So I'm going to grab all my positive. Well, actually, this right here, what's a +3 and a -3? It's 0, so that was just like a fun little dance move that he did. Yeah, he just wanted to dance. It's all right. Sometimes we got to dance. So what's 10 + 3 + 2 + 2? It is 17. All right, let's move on to C. Layla Graff, do you have one for me for C? Let's go for it. Forward 11. Okay. Forward 4. Layla was like, I'm just going to get off this tightrope as quickly as possible. Forward 11 and forward 4. Does it work? Yeah. But part of my directions, we're trying to use positive and negative. So let's try to find one that also uses a negative. So you're fine, this does work, but if we want to pull in some negatives, Lucas? Plus, like +11.
Yep, +11, +4, and +6. So now you're at 21.
So now we're at 21.
And then you subtract 6.
And then, so Lucas found a workaround. All right, Mr. Hudson wants us to use negative numbers, but I got where I wanted to get, so then I'm just going to add a little dance.
Yeah,
So guys, every time you have a number and its opposite, it really does nothing except make us dance, right? Like, all right, Eve, you got one for C?
+11.
+11, +4.
-4, and then +4.
Ooh, Eve didn't want to go past the platform. So here, Eve's at the platform. She dances back from the platform and then dances forward to the platform again. Nice. Antonella, do you have one for D? Yeah, we didn't have quite enough time. So we're going to leave D and E as just kind of for fun if you guys want to chat with each other. Do we sort of get the basic idea here, though? Cecil needs to end at the end of his tightrope. So now let's look at, there's this little math notes box at the top of, I should not have minimized that, this math notes box up here. I want to talk about multiplication using the quote-unquote generic rectangle, and I'm not quite sure why we called it the generic rectangle, when the diamonds that we use, we call like the magic diamond or something like that. I don't know. Generic just sounds mean to me. Let's talk about multiplication. What is multiplication? What is multiplication? Like, why do we multiply, Layla? It's repeated addition. So, I'm kind of skipping past some questions here. But let's say that we have a tightrope of, I'm actually just going to add my own slide because I want to. Say we have a tightrope of, I don't know, length 21. Since 21 was a popular number a couple years ago. So go ahead and on your graph paper, draw a 21. And what if I tell you I'm new at tightrope walking, which actually I have not been on my slack line for a while. If you've gone to one of those ninja places or whatever, you maybe tried a slack line. It's just like a balance line. You tried one?
My neighbor Amelia has one, and also we have a Ninja Warrior.
Nice.
I can't get on it because I'm too heavy and I touch the ground.
Yeah. You got to tighten up those straps. So if I go 3 plus 3 plus 3 plus 3, because I'm kind of scared, right? How many 3s do I need to get across the tightrope? So instead of writing all these out, which I think I need one more, what could I do instead? 3 times 7, right? 3, do it 7 times. Because I want to start encouraging us. Way back in elementary, you would have written this. And I think you are already fairly aware we'll never do that again. I would like to apologize to you on behalf of all of the math teachers who told you this was a good idea. Here's why we did it. Here's why we did it, though. When you're young, a dot here versus a dot here is very, very close. And getting you to put one there, or there, or there, we're like, what do they mean? Do they mean 3.7 or do they mean 3 times 7? So here's the thing. Now that we're using the multiplication dot, you got to be real particular with where you put it. Way up here so it's not confused with a decimal point down here. Or you can avoid confusion altogether and just use a parenthesis. A number against a parenthesis says how many of that I have. So this says I have 3 of 7. Literally, this would be read 3 of 7, and it is 21. So the generic rectangle says, you know how multiplication's kind of tough? Doesn't need to be. So let's say Cecil's got a really long tightrope. Like on Reddit last night, I put my blood pressure way too high watching a guy slackline across a 950-foot high canyon with no protection. Like, he was wearing clothes, but like no harness, no rope, and every time he fell, he just like wrapped his legs just right to catch the line. Oh, it was terrifying. But he was making like pretty big. It was a long slack line. So let's say what if we're talking in inches, right? Maybe we're talking in inches. Like, problems like 14 times, like, I don't know, 54. I'm just making this up. But go ahead and write this down. That looks really scary, right? It's not. It doesn't need to be, at least. It is scary, but it doesn't need to be. Because, guys, don't actually put your pencil down for a second. What if I change this? I just make it 10 times 54. Is that less scary? Yeah, right? Like 10, actually I should just move these things. So, not bad. It is okay to laugh at me when I'm fighting with technology, because it is funny. Or if I made this 14 times 50, that would be less scary, right? So this is our big, bad, scary. Break it apart. any like person who's played a video game knows if you hit the bad guy long enough, they break into pieces, right? So break it apart. I don't know if any of these jokes land anymore.
No, that makes sense. I play a game that does that.
Draw a rectangle. It can be a square, I don't really care, but we're going to break each of these numbers into their less scary pieces.
Oh yeah, and do that.
Did we just have a witch show up out of nowhere? An old lady in my classroom somehow. So, if we said 10 is less scary than 14 and 50 is less scary than 54, let's figure out a way to use both of those. So, we're just going to multiply piece by piece. So, 50 times 10, forget about that. Forget about all those. What's 5 times 1?
1 or 5.
You are so confidently wrong. Like, if I'm going to be wrong, I'm going to be confidently wrong. Guys, seriously, when you're multiplying with big numbers, just multiply the numbers you have and then get your zeros. I have 2 zeros. I have 2 zeros. It literally works that way. So 4 times 1, 4, get your zeros. I got 1. 4 times 50, we'll just do 4 times 5, 20, but then I have to get my extra 0, so 200. And 4 times 4? 16. Now we just add all these pieces up. I got 540 and 216. Put them all together. This would be 756. That's a lot less scary than it used to be. Try one on your own. Try, because I only have 2 minutes. Try 67 times 46. So we're going to break this into 60 and 7 and 40 and 6. And you can impress your friends with this too when you get good at it, and you can just kind of break up numbers in your head and say this plus this plus this, and it's right. And they're like, what? How'd you do that? Guys, multiplication is not easy, but it doesn't need to be scary. It's not easy, but it doesn't need to be scary. What's 6 times 4? 24, and then 2 zeros. 7 times 4? Wait, 7, 14, 21, 28, and then a 0. 6 times 6? 36, and then a 0 from my 60. 7 times 6. And when we add these all up, you get 3,082. Makes multiplication a lot less scary. Ooh, I actually have more time than I thought. People were moving around the hallway, and I don't know why. Look at your practice sheet. Look at 36. Let's do it together. Oh, this is your math notes box. What we just did, this 67, 46, look at your homework. It's your math notes box at the top. So now that you've done it, you can reference back to the math notes box.
So I didn't need to do all of that.
Yeah, you did. Because it's good for you. That's like saying if I'm going to eat vegetables tomorrow, I don't need to today. That's not true. All right, look at 36. 54 times 32. I'm going to do it on my actual paper so I have it done when people come to ask for help. So you guys should do it on your actual paper so it's like done on your homework. Whoa, crazy idea. You know what? And while you guys get a jump start on your homework, because actually you don't need me to do this, we'll check answers tomorrow. I might as well show you the video I was looking for earlier. This is a Red Bull Slackliner. Like Red Bull sponsored.
Wait, you want to
What?
look at that?
No, I can't like do flips and
No,
stuff.
it's just muted. It's just muted. Like the
I know. I'm trying to put on other music.